What is a power? So we're going to be taking a look at what is a power. A power, or more commonly called an exponent, but as we'll see, an exponent is a part of a power. So altogether, this is called a power. A power has two components to it, generally. Number one is the bigger number at the bottom, and that is called the base. The small number at the top is called an exponent. So powers are really incredibly useful when we're talking about repeated multiplication. So if I go to repeated addition, say for example, 2 plus 2 plus 2 plus 2 plus 2 plus 2. If I do this, what we have done in the past is we've created a new math operation that would say 2 times 6. And that really means 2 added to itself 6 times. So 2 times 6. And we've seen that new notation like that before. So a power really does that, but instead of repeated addition, it is repeated multiplication. So for example, 3 times 3 times 3 times 3 times 3 times 3. Here we are. So we're taking 1, 2, 3, 4, 5, 6 threes, and we're multiplying it all together. We can express it in the following way. The base is 3. The exponent is 6. So the 3 is called the base again. The top is called the exponent. And altogether, they're called a power. Please note that the above, 3 to the power 6, really means that we have 6 powers of 3. I think I wrote 7 there. 6 powers of 3. And what I'm going to suggest is that there's always being multiplied by a secret 1. And that might come in handy a little bit later. So when I write a repeated multiplication, I'm going to write it as an exponent. Note that this does not say evaluate. Evaluate means find the value. So unfortunately, right now, a calculator won't do me any good because all my job is to write it as a power. So this is, if I take a look, this is 4 factors of 7. 7 times 7 times 7 times 7. Just much easier to say 7 to the power of 4. And that is, I have 4 factors of 7 being multiplied together, or 7 multiplied to itself 4 times. Now this is where it kind of gets a little bit more interesting, I think. 3. If I take a look at the number 3, how many factors of 3 do I have? 1. So 3 can be written as a power in the way of 3 to the power of 1. So what we could also do is we could go from the power form and we can write it as an exponential form. The power form is 3 to the power 4. So now I need to write it as repeated multiplication. 3 to the power 4, I could rewrite it as 3 times 3 times 3 times 3. The exponent tells me how many factors of 3 I have. This next example is 2 to the power of 5. Now, I say 2 to the power of 5. That's the way we say it. But 2 exponent 5. Again, I have 5 factors of 2. So it's 2 times 2 times 2 times 2 times 2. So in other words, it's 2 multiplied to itself 5 times. Note, I did not say evaluate. You don't need to calculate the number here, and in fact, we're just writing it as repeated multiplication. If we go one more example here, or 3 more, these are 3 scenarios. Each of these mean a different thing. We're going to identify the base of each power, write it as repeated multiplication, and then evaluate the power. So here, I'm just going to write my base. My base and my base. There's my exponent in each of these. So here we have it. Well, let's take a look at the first example. My base is -3. Now, if you notice, -3 is in brackets. This is -3 multiplied to itself 4 times. Since the -3 is in brackets, all operations in there need to be carried out. So it's just much easier to see that it's -3 to the power of 4. And now when we choose to evaluate, we can go -3 times -3 times -3. Or we could group them like so. So -3 times -3 is +9, because a negative times a negative is a positive. -3 times -3 is +9. So when we evaluate this, the answer will be 81. After this, I encourage you to take a calculator and work this through. It's not easy getting the result of 81. You have to use brackets in your calculator. Now this, my next example, -3 to the power 4, no brackets. My base here is just 3. And if I was to write this as repeated addition, I would evaluate my exponent first. So I would evaluate 3 to the power of 4. So I got rid of that exponent. And then what is this negative in front? Well, this negative in front simply means multiplied by -1. And when we choose to evaluate this, -1 times 3 times 3 times 3 times 3, again, we can group them like we did before. This is -81. So a different result. And in fact, it looks so incredibly similar. But they have different meanings. Now, again, this one looks similar, but it's going to have a different meaning. The base here, for the last example, what is being repeatedly multiplied? 3. So I have to carry out the operation with the exponent first, because in order of operations, remember BEDMAS. So I'm going to write it as a repeated multiplication. So it would be 3 times 3 times 3 times 3. 3 multiplied to itself 4 times. And then it is the negative in front that I need to take care of. That it's -1. So -1 times 3 times 3 times 3 times 3, again, is -81. And for all 3 examples, if you follow the order of operations, it should lead you down the correct path. The first one is you had to work in the brackets first. That's why it was considered to be -3 multiplied to itself 4 times. The second and third one, we had to evaluate the exponent first. There was no brackets for the second one anyways. So that's why we multiplied 3 to itself 4 times. Last but not least, they meant the same thing, but people like to write it different. Negative, in brackets, 3 to the power 4. Well, 3 is being in the brackets, it just wants to be considered as 3. And if we raise 3 to the power 4, we had to evaluate the exponents first. And then this negative sign was considered a multiplication.